Hello and welcome to more Nerdy Rodent Geekery. Today I am looking at Torch Dreams. It's like a sort of Swiss army knife for all dream related imagery, as it says up here in the About section, making neural networks more interpretable for research and art. So scroll down, there you can see the sort of images that we get, and down at the bottom here as well there's some recommended reading. So if you have a look at those, one of those is this feature visualization paper, how neural networks build up their understanding of images. So that's certainly worth having a look at just the pictures, even if you don't read the words. All sorts of cool stuff going on there, little dogs and weird stuff. You get the sort of idea about the images that we're going through. So yeah, there you go, that. We're doing weird stuff like that. And here are some examples that I've done with this as well. So there's a nice weird one with some dogs, sort of feathered squirrel going on there, and I think you get the general idea. Some delicious guinea pig apple action going on there, and a bit of a mouse on the fence. So yeah, all sorts of weirdness like that going on, and even some videos too, which is quite good. So let's have a scroll down. So there, as you can see, it's quite easy. Pip install Torch Dreams. There you go. That's all you need to do. And let's dive in a little bit for that, because of course you need Python. So I am using Ubuntu 20.04 RTX 3090 for GPU acceleration of PyTorch. So CUDA 11 going along with that as well. And my Python is via the Anaconda individual edition. So I can conda create -- name Torch Dreams Python 3.9 and then simply activate it like so. There we go, activated my new Conda environment, which allows me to install PyTorch, Torch Dreams, ImageIO, FFmpeg, and Matplotlib. There you go, all those go through. Of course, you can just pop to the PyTorch website, install, start locally, stable, Linux, Python, CUDA 11. There is that exact same command, pip install torch. So that's me installing Torch there, and then you're ready to go. I have also made a directory, Torch Dreams, just to put all my images and examples in, because as you can see there are quite a few scripts. There's quite a few scripts, and these kind of tie into going through these content bits here. So minimal example, not so minimal example, etc. All this sort of stuff here. So let's have a little start with this minimal example. Now, there's two sort of things to be looking at here. Obviously, you're doing a bit of coding. It's Python, but it's all right. You can just click this and you're copying and pasting. But the two things we're looking at mostly are the models here. So this model's Inception v3, and also the layers within that model. So that model.mixed5b, if you remember from here, we've got like layers mixed 4D and 4E and all that. Yeah, there's lots of words like that. And so don't worry too much about it being coding. You're just doing a lot of copying and pasting and changing words and things. Now, these models, these are all Torch Vision models here. So as you can see, you could just copy and paste that. There you go. And then you've got all the models. You can set your model equal to that. But there's quite a few in there. So AlexNet, VGG, ResNet, DenseNet, Inception, GoogleNet, all that sort of stuff. And if you scroll down, there's even more detail there. So yes, there's a lot of models, and within each of those models you've got loads and loads and loads and loads of layers. So yeah, there's lots of things to play with. Absolutely loads of things to play with. So let's start, shall we? Let's start with this minimal example. So minimal example over here, minimal example, open with text editor. There you go. So that's a minimal example, just copied and pasted. There you go, copy, pasta, there. Done. All right, so let's run this. Let's run it. Python minimum example.py. There we go. Right. So this is basically, as easy as it can get. Runs through all the default options, 120 iterations. Bang. There you go. There is your dream-like image. Ooh. Zoom in a little bit if you want, but yeah, looks pretty weird, doesn't it? Okay, minimal example done. Fantastic. But what are all these? So I've seen these models. Yeah, I've got all the models from here, but what's this mixed 5B? What's all that about then? What's going on there? All right, let's have a look at that. So same thing here, minimal example, exactly the same, but you know, the astute among you will have noticed I've added a print statement up there. So let's run it again, shall we? Python. Minimal example. Number 2. So exactly the same as before, apart from, oh, there we go. We've got loads of text. We've got loads of text. There we go. Different one there. 5C instead of 5B. But I've got all this text. And how did I know about the difference between that 5C and 5B? Well, there it is. There it is. It's all in here. As you can see, we've got things like this mixed 6B, branch 1 by 1, conv and batch norm, and, you know, all these different things. So if you're not sure what any of the names are in any particular model, there is one easy way to do. You can just print it, and there it is. And I've actually got a few of those saved so that I can refer to them later. For example, there's the ResNet model. As you can see, this is slightly different names. So you've got layer 4, and you've also got, you know, different layers within that. And yeah, so each structure is different as well as the names. So certainly worth having a look at those if you're not familiar with the names in each model. Right, so there we go. So dead easy, print, and that will show you what's inside the model. Fantastic. Right, so we've got the minimal example done. Awesome. What's this one? Not so minimal example. All right, what's going on here? It's exactly the same sort of thing as last time. Now remember, when you're copying and pastoring these, you do your copy paster. Only this one at the top has the imports and the from, but you'll still need those. You'll still need those. So if you do the copy and paster, remember to add the imports at the top. Right, anyway, so here we're using the same model, Inception version 3, CUDA, of course, GPU accelerated. And here you can see we've actually got loads of options that we can throw in there. So if you want a slightly bigger image, you can change that. So, you know, if you want it 1920 by 1080, that's fine. You can put it in there. Number of iterations. You can do rotations and scale, min, translate, custom functions, and all that sort of stuff. So yes, lots and lots of options. Let's just close those down. Lots and lots of options for you to play with. Now these obviously all sort of build on each other as well. So we've gone from minimal to not so minimal, and let's have a look at a custom function now as well. So visualizing individual channels. So within each of those models, I've also got these individual channels as well. So we're doing the same thing here. Got a layer and a channel this time as well. So this is just copy pasta from here, but I've put layer and channel just up at the top there because it's yeah, I like things up at the top, changing things up there and leaving things down below. Anyway, so here we see the layers to use. We've got model mixed 6B branch 1 by 1 conv. So mixed 6B branch 1 by 1 conv. Yep. Okay. So now we can see that we've got this number here, 192. So that's basically the maximum number for the channel here. So if I was to set that to 192, for example, let's do Python individual channel custom function, then that will go, oh no, that's wrong, that's out of bounds. You can't do that because it starts at 0. So it's 0 to 191, which is 192, and then you can do it. Then you can do it. So remember, it starts at 0, and you'll be fine. You'll be fine. So we should get a little image. There we go. So yeah, little image. Looks a little bit weird. So yeah, you got another 191 of those to play with. And yeah, as you can see, it's starting to grow, isn't it? So we've got that massive model with all those different layers, and each one has all sorts of channels, and yeah, so lots and lots of things to play with. That's how you look at them individually. Okay, now the fun things like I showed you earlier in the video, the caricatures. The caricatures, let's have a look at those. So where are we? Caricature. Let's open that one. So again, you can just copy pasta from the web page. Copy pasta. There you go. And so I'm taking a picture of a squirrel here. Little picture of a squirrel. Let's have a look at the picture of the squirrel. Pictures. Picture of a squirrel. There we go. Okay, so that's like picture of a squirrel. Okay, so that's how the squirrel starts out. And yeah, we're gonna dream squirrel. We're gonna dream him. What are we gonna dream him with? We're gonna use GoogleNet this time, and model Inception 4C and 4B branch 1. I know, right? Gonna do power 0.9 and 256 iterations for this one. And we're also throwing in an extra function here. So we've just been showing them previously with that plot.im show. And if you want to save it, then you know, you can just put param.save. There's your image param. Just put .save on the end, whatever you want to save it as, and that will save it as that. So let's run this through. Caricature. So that will take the squirrel, run it through those two layers, 4C and 4B, 256 iterations, power 0.9. Says higher is more exaggerated features, so you can put the power up if you want more dream. Give me more dream in my picture. You've got lots and lots of control over everything you want. And there is my squirrel. Now you see also the plot is a little bit smaller, so the squirrel's actually a little bit bigger. So if we have a look at character param output, whoops, not that one, that's output 2, that one, there you go. So that is the actual size of the squirrel. There he is. So yes, when you save it, it does save it the full size. Nice, very nice. Okay, so caricatures, yeah, lots and lots of fun with caricatures. Now you can also visualize features from multiple models simultaneously. Ooh, okay, I know, right? So where are we? Multiple models. Open that one up. Close that one down. So here exactly the same thing as before, but we're using 2 models and 1 layer from each of those models. So you've got an inception layer and a ResNet one as well. So there, those 2, and you can also pick the sort of individual channels from those as well. So you can see how all these different examples are sort of building on each other. Let's have a little look at this one. So Python, multiple models. So remember what I said about it being a Swiss Army knife? Yeah, you've got all these different things that you can just, even though you don't know any Python, you can just copy pasta them, change a few numbers, and yeah, you get some cool looking images. So there's a little weird one there for you. Yeah. So that's 2 models, and there's more. There is more. You're right. Okay, so if we scroll down a little bit more, you've got some custom transformations there, and another fun one here is feedback loops as well. So you can basically feed one back into the other one, and yeah. Okay, so let's have a look at this one. Here's a bigger one than that one, so it's like the copy pasta of that, but I've added another one in there as well. So yeah, so again we're using the Inception v3 model, and it starts off with 256 iterations, then 25, then 25. So let's just throw this one in. Feedback example. So there you can see we've got the image parameters, and it starts off in that mixed model 5B, 256 iterations. Then the image parameters for that are image param, so it's feeding itself back in, does 25 iterations of that, then 25 iterations of that, and then shows the image. So there you go. As you can see, it's quite heavily saturated and lots of contrast in there, but there you go, lots and lots of feedback. You can also use custom images there. So this is very similar to the caricature before. So param there, custom image, that's the custom image you want. So I'm using a hamster, passing it through the Inception v3 model, and that layer mixed 6C, slightly lower learning rate when you're using pictures. They do mention here, so lower the learning rate when you're using pictures, and you may want to use grad clip as well. So let's throw this one in, custom image. There we go. So I'm doing this one for 120 iterations, so nice and fast. And we should get quite a good picture of a hamster. There we go. There is a hamster, apparently. I'm pretty sure you can see the hamster in there. It's just a very rainbow sort of firework sparkle hamster. Yeah, there you go. Dream hamster. And even more working on models with different image normalizations as well. More just a sort of note there if you want to play with different normalizations. Now, the other one that's really, really fun is this masked image parameter. So exactly the same as before, but you're applying more or less dream, depending on whether there's white or black there. So as you can see there, it's normal at the top and very dreamy at the bottom, or this way around, very dreamy at the top and sort of normal at the bottom. So these come out quite well. I do like the gradient. There's an example mask there. So not very dreamy at the top, and all very dreamy at the bottom. So where's the masked output? Masked image. There we go. So again, copy pasted from there. Very easy. So this mask obviously has to be the same size as your picture. So there's a 512 by 512 vertical gradient mask, runs through the Google Net and Inception 4B layer, and saves it. There you go, masked param output. So again, yep, that's that particular there. So if I change this picture, for example, I could change that to 4. There we go. Python masked image. There we go. And that will go through 150 iterations. My masked param output then becomes even more weird. There you go. Normal at the top, weird at the bottom. Like it. Obviously you can have any sort of mask you like, but yeah, that's I like playing with that one. I like playing that one and the caricatures. Those two are my favourite. There's a few other conveniences that they've got down at the bottom there as well. But another link that is also worth having a look at, let's just close these ones down, is this Dreams notebook. Again, the same owner of the repository there. We pop over here. Oops, there we go. Got it there. So yeah, there's another load of notebooks there. All sorts of ideas and things for you to play with, including one with videos. So let's have a look at the video example as well. So this is the video example. I'll start running this already, as this will take a few seconds. So scroll back up to the top. So this is using FFmpeg, image.io, and you basically set the FPS, number of steps you want in each frame. Again, using the Inception v3, which layers you want to use, writing out each frame. You've got the Dreamy Boy in there again, width and height of those things, running it through the different channels, and then, basically making your video so it goes from one, sort of slowly transitioning through into the next one, and then finally changing into something else at the end. So that should, there we go, so that's come through. Then we've got our example video, and there it is, sort of morphing between the different channels there. Yeah, nice. Very, very weird. So there you go. As mentioned, very much like a Swiss Army knife for dreams. Absolutely shed loads of things that you can do, loads of examples. Even if you don't know Python, you can just copy pasta, and yeah, absolutely loads of things to look at. I still haven't tried all the models, to be honest. So yeah, I'm just getting through the basics, but absolutely loads of fun making lots of weird pictures. Hope you enjoy, and we'll see you on the next one. Rodent out for now.